Hello everyone, welcome back to our GRE training series. Today we'll be tackling algebra, specifically inequalities. But before we begin looking at specific problems or questions, let's refresh our memories on inequality symbols. Now we have the first symbol here, that is less than. We have less than or equal to. We also have greater than. And lastly, greater than or equal to. Let's look at our first example. We'll start with a relatively simple one here. We have this inequality, -2 less than or equal to x less than or equal to 3. Now, the question reads, how many integers satisfy the inequality? And here satisfy means basically which integer values of x will make this inequality correct. So here we can tackle these problems in two main ways. First, we can just list these integers. Now we know that x is greater than or equal to -2. So our integer list starts from there, and then it runs up to 3. So we have -2, -1, 0, 1, 2, and 3. Because x is also less than or equal to 3. So we have 1, 2, 3, 4, 5, 6 integers. Another way of looking at this is by using the number line. So as we know, the number line increases to the right and decreases to the left. So if we have 0 here, we'll have 1, 2, 3, 4, and so on and so forth. Then these sides we have -1, -2, -3, -4, and so on. So where do we start our x from? We have x is greater than or equal to -2. So it starts here. Then it ends at x is less than or equal to +3, which is this here. So this line from 3 to -2 inclusive represent our inequality. So we can just count the integers here. That is 1, 2, 3, 4, 5, 6. So again, we have 6 integers that satisfy the inequality. Let's look at another problem. In this case, we have the inequality, this one, and we are asked to solve for x. So we have -3x plus 5 less than or equal to 17, and we want to solve for x. The first thing is to simplify this inequality. And we start that by subtracting 5 here. And remember, whatever you do to one side of the inequality, you must also do to the other side. So we have -3x plus 5 minus 5, that is 0. So we just have that there. Then 17 minus 5, that is 12. The next step is to divide both sides by -3. So we have that there. Before we simplify this further, let's remind ourselves of something here. For inequalities, when you divide or multiply by a negative number, then you have to flip the sign, right? So if the sign was greater than, and you divide or multiply by a negative number, the sign becomes less than. A quick example will illustrate why this should be the case. Let's say you have this inequality of 4 greater than 1. Then you multiply both sides by -1. You'll have -4 greater than -1, which makes no sense because -4 is not greater than -1. But flipping the sign to read -4 is less than -1 makes it right. The same thing applies with division that you can try on your own. So basically here, after dividing this, we should flip the sign to have x greater than or equal to -4. And that is the solution for our inequality. Another example. Here we are asked, what is the smallest even integer x that satisfies this inequality? Again, we start by simplification. So we have 5 minus 4x divided by 3 less than 6. Then we multiply both sides by 3 to get rid of that denominator. We have 5 minus 4x less than 18, right? Then next, let's subtract 5 from both sides. Then we'll have negative 4x less than 18 minus 5. That's give us 13. Then we divide by negative 4. Remember to flip the sign so that we have x greater than negative 13 over 4. Now that is as far as we can simplify this inequality, but we are not yet done with the question because it asks for the smallest even integer that will satisfy this. Now, you don't have to work this out to its last bit, but you can just tell from this that x should be greater than 13 divided by 4. That will give you 3.2 something. So the first integer that is greater than this, the first even integer will give us our answer, which in this case should be negative 2. Let's look at it on the number line, which we'll just use for illustration, but you don't always have to use it. So let's say we have this number line here. Then let's say we have our negative 3.2 somewhere there. Then the next integer after negative 3.2 should be, of course, negative 3. Then you have negative 2, then negative 1. So the first integer after negative 3.2 is negative 3. But negative 3 is not even. So we move. The next integer after that is negative 2. Negative 2 is even, and it is the smallest in this series because remember, our x is greater than or equal to negative 2. So our answer to this question is negative 2. All right, let's proceed. Let's look at another example of a double inequality. Double here means we have two inequality symbols. So the question reads, if x is an integer and if we have this inequality here, which of the following must be true? Which of the following must be true? So again, as usual, we start by simplification. So we'll have negative 5 less than 3x plus 1 less than 10. Simplify by the first step by subtracting 1 from all sides. So we have negative 6 less than 3x less than 10 minus 1, that is 9. Then let's divide each term by 3. So we have negative 6 divided by 3, that gives us 2. Yes. Then we have 3x divided by 3 is x. Then finally 9 divided by 3 is 3. Right. Now, again, we have simplified this as far as possible. So we can just go back to our answer choices and see if we can figure out the answer using this simplified version of the inequality. So let's start by looking at the right-hand side of this inequality where we have x being less than 3. So here, anything that does not satisfy x less than 3 is out of the contention for the right answer. So for example, here we have x being less than or equal to. But our simplified inequality requires x to be less than 3, not equal to. So we'll rule out this. For the same reason, we'll eliminate this and also eliminate this one here. So that brings us to two answer choices, A and C. Where for A we have negative 1 less than or equal to x and also less than or equal to 2. For C, we have negative 2 less than or equal to x, which is less than or equal to negative 2. Now we are done with the right-hand side of this equation. Let's look at the left-hand side. We'll start by this. X is greater than -1, which is right because our x is greater than -2. So that makes sense. Then we have C, where we have x is greater than or equal to -2. And this is wrong because our x is just greater than -2. It is not equal to. So we eliminate C and remain with A.
You're watching Success with Bob Mwiti Show, presented to you by Upstake America. Upstake America is a consulting company that helps immigrants find amazing higher education and job opportunities in the tech industry in the United States. You can find our programs by going to www.upstakeamerica.com. Upstake America, we wake you up to the unlimited potential.
Another example, in this case, we are having a quantitative comparison question where we need to find out whether quantity A is greater than quantity B, or they are equal, or whether we cannot tell the relationship between the two. As usual, simplification, looking at the inequality will help us a lot. So we have here RT less than 0, less than -R. We look at this first half of the inequality and then the other half and see which information we can glean from it each that can help us solve the given question. So here we start by RT being less than 0. So which information can help us here? RT is less than 0, which means RT is negative. RT is negative because anything less than 0 is negative. And if RT is negative, which information again can we tell from that relationship? We can know that either R is positive and T is negative, or R is negative and T is positive. Yeah, this was the case because negative times a positive will always give us a negative answer. So now we are done with the left-hand side. Let's look at the right-hand side. Here we have 0 less than -R, which we can also write as -R being greater than 0. Now we have a negative sign here, but we also have this term being greater than 0. And we know that anything greater than 0 is positive. So that basically tells us that -R is positive. Now for -R to be positive, R itself must be negative because a negative times a negative gives a positive result. So now we know from this relationship that R is negative. Then we come back here. We know that R is negative. So we can cross this out so that we know that R is negative and T is positive. Now if T is positive, then quantity A will definitely be greater than quantity B because any positive number is greater than 0. So our answer here is quantity A is greater than quantity B. Another example here, we will be seeing how we can use rules of multiplication to solve some inequality problems. So here we have two inequality expressions. We have -8 less than x, which is less than 6. And we also have -5 less than y less than 6. And the question asks us to find the maximum possible value of xy. In essence, we are being asked, if we were to multiply any value of x and any value of y, what is the greatest possible product of xy we can find? Now, let's look at values of x here first. We'll just be looking at the minimum and the maximum values. And for minimum x here, we'll have the first number that is greater than -8, that is -7. And for the maximum, we'll have the first number that is less than 6, that should be 5. For y, we'll have the minimum as -4 and the maximum as 5. That is the first number, integer, less than 6. Now here is where most people make a mistake. They know that positive numbers are greater than negative numbers. So when they come to this point, they just take 5, multiply by 5, and get 25, which would be wrong in this case, because you should not forget that a negative times a negative will give you a positive outcome. For example, in this case, we have -7, and if we multiply it with -4, we'll get positive 28, which is greater than 25. And it so happens that 28 is our answer for this case. Now, a good way to remember to look at all scenarios is to list the maximum and minimum value for X and Y when you have such a question. For example, here, we can list here 7, 5 for X, then Y, we have -4 and 5, then multiply each value of X here with each value of Y and see what you can get. So -7 times -4, 28. Then -7 times 5, that is -35. Then 5 times -4, you get -20. And finally, 5 times 5, you get +25. So among all these, we have 28 as the maximum value of XY. And that brings us to our last example for today. In this example, the question reads, if P is a negative number and we have this inequality here, which of the following must also be a negative number? Now, before we tackle this problem, let's remind ourselves of another thing, that is the absolute value of a number. The absolute value of a number is the value of that number without regarding its sign. For example, the absolute value of -4 is 4, and the absolute value of 4 is also 4. So basically, the absolute value of a number is just the value of that number without regarding its sign. So now let's come to our question. We have this inequality here, 0 is less than S, which is less than the absolute value of P. Remember here, it's only the absolute value of P that is positive. But whatever is inside here, that is P itself, can be negative or positive. Although we are told in this question that P is negative. Now, what information can we get from just looking at this inequality? We can see here that 0 is greater than S, or in other words, 0 is less than S, or in other words, S is greater than 0, which tells us that S is positive, right? Because any number that is greater than 0 is positive. Again, we can tell that P itself, without regarding its sign, is greater than S. Because if we have this relationship here, S less than the absolute value of P, then it can only be true if P itself is greater than S. Look at this example. Say you have something like 4 is less than the absolute value of -7. This can only be true if 7 itself is greater than 4. Because if we reverse these numbers and have something like 7 is less than the absolute value of -4, this will not hold true. So in our case here, we also know that P is greater than S. Now let's come to our answer choices. Before even we use this information, there is something that can help us eliminate some answer choices and narrow them down. We know that any number squared is positive, gives a positive result. For example, -2 squared gives us +4. So here we have a term in bracket squared. The result will be positive always, regardless of what's inside the bracket. So we rule that out. For the same reason, eliminate that. And for the same reason, eliminate that. So just by using that knowledge, we have narrowed down our answer choices to 2, D and E. And now we can use the information we have gleaned from the inequality. We know that P is greater than S. So here we have a big number squared minus a smaller number squared. The result definitely is positive here. See, if we have a big number like 7 squared, and then we subtract from it a small number like 1 squared, we'll have a positive result. Then we come to E. We have a small number squared minus a bigger number squared. The result here is negative. An example, we have 2 squared minus, minus 3 squared. We'll have here 4 minus 9, which is a negative result. So definitely our answer here is E. And that brings us to the end of our inequality episode for today. Thanks for watching, and I hope you have learned something. Let's meet again next time. Bye-bye.